Alright, this video is for applied calculus. We're going to talk about the review chapter. So the first part of this course is on sections R1 through R5, which are really review topics that you should have known coming into the class. We're going to just touch on them briefly. We're not going to spend a lot of time on them. For section R1, we talk about graphs and equations. And when I'm talking about graphs and equations here, for this section, we're really just going to talk about how you graph by plotting points. We're going to review graphing a line in the y equals mx plus b, the slope-intercept form. But we're not going to spend a lot of time in terms of graphing. So the first thing, let's talk about ordered pairs. Okay, ordered pairs are a set of coordinates which we generally call x comma y, where x represents distance on the x-axis and y represents distance on the y-axis. So, we have our coordinate system. Typically we call this the x-axis. It's one moving up and down we call the y-axis. And usually there's values labeled on here. When I do this for our class, I will just use them as if they were one apart. But they could have different scales, so make sure you look out for that. But in this case, if this x value is 1, this y value is 2, this point here would be at the point x value of 1, y value of 2 would be at the point 1 comma 2. And continuing onward here, we have just a couple examples of graphing. So if I said to graph y equals negative 3x plus 1. This has that y equals mx plus b type form. When I say y equals mx plus b, you've probably seen it before. The y and the x stay y and x, they stay variables. The m represents the slope. The b is telling you about the y-intercept as a coordinate. Usually we write that as 0, comma, b. Y-intercept meaning where it crosses the y-axis, remember. So for this graph here, right, for y equals negative 3x plus 1, we know that the slope, m, is equal to negative 3. It's whatever value's in front of x. And the y-intercept we have 0, comma, b, which is this constant, so we'll call it 0, comma 1. So if I wanted to plot this line, right, I draw my x and y axis. So here's x, here's y. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And as I said earlier, we'll assume these are all one apart for the scale on the axes. You always want to plot the point first. We want to plot that y-intercept first. So 0, 1 means the x value is 0, the y value is 1. It should be on the y-axis. That's why we call it the y-intercept. And your slope is giving you directions. It's telling you how to move to the next point from the point you've already plotted. So if the slope is negative 3 as a fraction, we write that as negative 3 over 1. And remembering what the y, or what the slope tells you, the numerator tells you about the change in y, the denominator tells you about the change in x. So the numerator's got a negative 3 there, so that's telling you to move down 3 because that's the change in y. So down 1, 2, 3 units. The denominator is telling you about the change in x, so we're going to move to the right 1 unit. And then you could plot your line through those points. If you wanted to be more accurate, you could again go down 3, so down 1, 2, 3, and then 1 to the right, and then plot the next point there. But the point being that you draw your line through there, arrows on the end, and this is the line y equals negative 3x plus 1. when I'm looking at this, the other thing to point out is if you're to graph this in MyMathLab, the way you graph is you want to click on the point on the y-axis first, that y-intercept, click, let go, and then go to the next point, you click and let go, and that'll graph the line for you. Let's take a look at another example. For this next example, if I said to graph (3x minus 2y equals 4), the first thing to notice on here is that we don't have the y equals mx plus b form, but we can get into that form. So the first way we'll do that is to isolate y on the left side. So I'll subtract 3x from each side of this to isolate the y term. And the 3x minus 3x are going to cancel out, and we're left with negative 2y equals, because I want the mx plus b form, I'll put the x term first, so negative 3x. And then it's a positive 4, so we put plus 4 there. And then once I have that, remember, I'm trying to get y alone, so this is negative 2y means negative 2 times y. So to remove the negative 2, we divide by negative 2. And remember, you're doing that to each term on each side. The reason you're doing this is because it has to be balanced. You're doing it to each side to keep the equation balanced. So on the left side, these negative 2's cancel. I'm left with y equals. Here, a negative divided by negative makes that a positive 3 over 2. The x comes along, you can write it right next to it or in the numerator, but it is not in the denominator. And then positive 4 divided by negative 2 is minus 2. So now I have the y equals mx plus b type form. My slope is whatever's in front of x, so it's the 3 halves. Don't put the x with it, it's just whatever number's in front of x. The y-intercept, remember this is an ordered pair. The x value is always 0 because that's how it's on the y-axis. Comma b. B in this case is negative 2. Make sure you take the sign with it. And then once you have that, you're ready to graph similar to how we did earlier. I will draw myself an x and y axis here. So here's x, here's y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember how you graph. You first plot your y-intercept. In this case, it's 0, negative 2. That's negative 2 on the y-axis. It shouldn't be hard to find that. And then using our slope, 3 over 2, the numerator tells you the change in y. Since it's positive, you're going to go up 3 units. The denominator tells you what the change in x. Since it's positive, you're going to go to the right 2 units. So from the point you've already plotted, you go up 1, 2, 3, and to the right 1, 2. Plot your next point. That's all you need to graph. Any line is 2 points. Draw your graph straight through there, arrows on the ends. Keeping in mind that when you do this, one of the reasons that you know it's a line is that the x and y values both have powers of 1 on them. So that's how you know you're graphing a line. If the powers were differently, it tells you different things. Next example we see, we'll look at, has a different power on x. So if I said for this example, let's graph y equals x squared minus 2. And the first thing you should notice is that the power on x is 2. The power of 2 tells you that it's going to be a parabola. So this tells us that a graph of the shape of a parabola, and you should have seen parabolas before. They kind of have this bowl type shape or a U-type shape, arrows on the ends. This one is a parabola opening upward. You also could have a parabola opening downward. In this case, the one we know is opening upward because the x squared has a positive coefficient in front. The number in front is positive 1. So we know it opens upward. If this was negative, it would be opening downward. This minus 2 here tells us that the parabola y equals x squared is shifted down 2 units. So this really tells you that it has a shift down 2 units. Now, if you didn't know what the original parabola looked like, shifting it down 2 doesn't really help you. The way they teach it in this section for our textbook is really just to look at points and plot them, corresponding to where they would be on the graph. So, we can set up a little chart here where I will have an x value will sub in. I'll have the equation, the y equals x squared minus 2. And then we'll just list the corresponding x comma y ordered pair that goes with it. Now when I do this, I'm going to pick a couple points to the left of 0, points at 0, and to the right of 0. That's typically the easiest way to do it. But you don't have to. You can really pick any x values you'd like. I'm going to start by picking x as -2. If x were -2, then we'd have y is equal to -2 squared minus 2, which makes this really -2, the quantity squared. Notice I put parentheses around it. That makes it a positive. So you have 4 minus 2, which equals 2. So the coordinates x comma y, the x value we picked, -2, the y value got out was 2. So we know the point -2 comma 2 is on our graph. Similar, we can pick some other points. Let's say I picked -1. We'd have y equals -1 squared minus 2. -1, remember, a negative squared, again, that's going to be +1. So you got 1 minus 2, which it ends up equaling -1 here. So the next point that I have on the graph would be -1, -1, x comma y. And we could plot a few more. If I choose x to be 0, well, then take a look at what happens here, right? X squared be 0 squared, so it's 0 minus 2. So we get y equals -2. So the point 0, -2 is on our graph. And we could continue just, a couple more points on the other side. When x is 1, we'd have 1 squared. 1 squared is 1 minus 2. So we get y equals -1. So you'd have the point 1, -1. And I'll just choose x equals 2 for the last point. We'd have y equal 2 squared is 4, minus 2 gives us 2. So we would have the point 2 comma 2. And now we're ready to graph this. So to graph this, we're going to plot the points we know. Now we know the basic shape of it should be a parabola, but this will help us be a little more accurate. I'll plot some tick marks here on each axis. Remember, I'm going to assume these are all 1 apart. Make sure you're paying attention to the scale, though. If you're doing a problem yourself, the problems won't always have a scale that's 1 apart. And we'll plot the points we know. So the points that we had were -2, 2. So the x value is -2. The y value is 2. So it'd be there. -1, -1 would be right here. We have 0, -2, which would be right here. We have 1, -1, so x value is 1, y value is -1, would be right there. And 2, 2 would be here. Now remember, this has a U-type shape, so make sure you don't put a point here going down, right? You really want to make this a curve. And up and back through. Arrows on the ends. These do go on forever in both directions, so you keep going with any x values out to the left or the right, and you could find corresponding y values. This point here, the highest or lowest point, in this case lowest, for a parabola is called the vertex. You should know that. A parabola y equals x squared would have been centered at 0, 0. This shifted down 2, moved every point down 2 units, including the vertex. That's why it's where it is. We know this opens upward, right? So it has a minimum here because if this is opening upward, the vertex is at the bottom. We know it opens upward because the coefficient was positive. So that's really how you would, graph by plotting points. We're not going to cover graphing this using different formulas. Maybe a little bit later in the course we will, but not just yet. The last part of this first section talks about a couple theorems involving compound interest. So I'll label them with, theorem 1 and theorem 2. Theorem 1 is just a special case of theorem 2. Theorem 1, and this is just from the way the textbook will label it, tells us if an amount, which I'll call capital P, is invested at interest rate, which I'll call lowercase I, and maybe I should put here I is as a decimal. So if they give it to you as a percentage interest rate, you have to turn it to a decimal. And compounded annually, and that matters, right? It tells you how often they compound the interest. In T years, if it's left untouched, it will grow to, and they have a formula for this. So we have A is equal to, right, that's the amount. It's equal to P. P, this initial amount we call the principal, right? That's that amount P that we talked about as a principal, initial amount invested. And then in parentheses, we have 1 plus I, the interest rate, and that is raised to the T power, which was that time in years. So this is a formula you should know for interest compounded annually. So if I gave you an interest rate and I gave you a time and an initial amount that you invested, I could tell you how much money you would have. You could also use this for loans. As long as I give you 3 of the 4 variables, you could always solve for the other parts. And we'll talk about that a little bit later in the course as well. So let's take a look at an example that uses this. If $4,000 is invested at 8% interest, so at 8% interest compounded annually. Annually means once a year. How much is in the account after 3 years? So, I'd recommend pausing the video when I give you an example like this and trying it on your own, and then checking to see if your answer matches the answer that I provide. Taking a look at this one, first off, this compounded annually is telling us we're using this formula. The way interest is compounded tells you a lot about how to approach the problem. So when I say compounded annually, that means I'm using, A equals P times 1 plus I raised to the T power. And now I'm just going to fill in for the pieces I know and what I'm looking for. So first off, if I ask you what I was looking for, this how much is telling me, how much is in the account after 3 years. That's A, so that's what I'm looking for. So I'm just going to keep that part A. It's my unknown. P, remember, stands for principal, the initial amount invested. In this case, that's $4,000. So we got A equals 4,000. And then in parentheses after this, we have 1 plus I. Now I is the interest rate. Now they told us it was 8% interest as a decimal though, so I is going to equal to, if you 8%, that's 0.08. If you don't remember how to convert a percent to a decimal, you want to move the decimal place 2 places to the left. You could also think of this as if you divided a percent out of 100, that'll always give you the decimal equivalent. So 8 divided by 100 gives you 0.08 if you're looking at that in your calculator. So you got 1 plus 0.08. And then to the power of T, T was the time in years, so that's 3 years. So we put 3 up there. And now I want to, evaluate this. So the easiest way to look at this is to, simplify the inside of those parentheses first. So you got A equals 4,000 times 1 plus 0.08 is just 1.08 raised to the 3rd power. And if you have a calculator that displays everything on the screen, similar to the one I'm going to show you right here, this would be the calculator model I would recommend. I mean, it comes in a variety of colors. But the important thing is to understand that if you have one like this, it'll display all the operations on the screen. You could type this right in as you see it. I could write 4,000, then in the parentheses 1.08, close the parentheses, and then this little caret here raises it to the power, so that's raising it to the 3rd power, and hit enter, and it'll give you an answer. So I end up with, I have this equals, right, so A equals 5,038 point, now I got 0.848. Now remember, this represents money, so I'm going to round that to 2 decimal places for the cents. So 0.85, because that 8 rounds that 4 up. Remember, if you're rounding, it's based off of the number coming after the last digit you're trying to round to. Being 5 or above, you round up. 4 below, you'd keep it the same. So A equals $5,038.85. And, you know, that would be your answer. If you don't have a calculator that displays all the operations on the screen, you would actually have to do the 1.08 to the third power first, hit enter, and then multiply by the 4,000 to get the same answer we did, just following your order of operations. All right, and we'll look at one more theorem that really just is the general case of what we just talked about. So if I call this here Theorem 2, because that's how the textbook describes it. Theorem 2 says, if principal P is invested at interest rate I, again as a decimal, and compounded n times per year. So they're figuring out interest n times per year. The previous example was annually, right? So it's saying n times per year. That matters. Compounded n times per year. In t years, it will grow to this amount. So if it's left untouched, the amount you have in your account, A, is equal to the principal times in parentheses. So that part's similar. You still have 1 plus, now this is where it changes. You have plus I divided by n, close parentheses, and the power is going to now be the nt power. So this is the formula you would use if you have interest compounded n times per year. The previous formula was if you had it compounded annually. Annually would mean 1 time per year, so all that happens is that n would become 1 in that case, and then that's how you got the formula we had on the previous page, right? The 1 plus I all raised to the t power here is what would happen if n was 1. So compounding n times per year, you know, this is the general formula. I just memorized this one. If it's annually, you know n is just 1. So it's going to be in the words. You know, sometimes you might hear it say quarterly. That'd be 4 times per year. It might say, you know, semi-annually. So the number of times that it tells you in the problem will usually be in the words and how often it's compounded. A little later in the course, we'll learn about interest compounded continuously, and that'll be something different. It'll be a different formula. So let's just take a look at an example using this one, just to make sure we understand it, and that will be the end of the first lesson. So suppose $4,000 is invested at 8% interest compounded quarterly. How much is in the account? After 3 years. And we assume it's going to be left untouched. So remember, when I'm going through this, you should probably pause this, try it on your own, and then see how it works out for you in terms of getting an answer. So first thing I would notice is that, you know, the words compounded quarterly. That's telling you something. It's letting you know that the information you should use is telling you to use this formula above, because we're talking about interest compounded n times per year. So I'm going to use the formula A equals P times, in parentheses, 1 plus I over n raised to the nt power. And once I've done that, you know, I'm thinking about, what am I looking for? Well, how much tells me I'm looking for A, so I'm going to keep that as A. It's the amount, right? How much is in there after 3 years? P is the principal, so that comes from the amount you invested, right? So that's the $4,000. Times, here in parentheses, you got 1 plus, now we got I divided by n. I, remember, is the interest rate. Here we got 8%, So I is equal to, as a decimal, 0.08. Remember, you move that decimal to the left 2 places, or you could say 8 divided by 100 gives you that. So 1 plus 0.08 divided by n. Now n, remember, has to do with being compounded n times per year. When they say compounded quarterly, quarterly means n equals 4 times per year, and you have to know that. So this would be 0.08 divided by 4, and it's raised to the nt power. N, again, we just said was 4, times t is the time in years, which is 3. Once you have that, I'd simplify the formula first. All right, so I'd simplify the formula first here, and you'll be left with A is equal to 4,000 times 1 plus 0.08 divided by 4 will give you 0.02. And then to the 4 times 3 power is to the 12th power. So we have A equals. Now, don't bring this 12 to each piece in here. You really want to think of this as, you know, just one single term before you raise it to the power. So you got 4,000 times 1 plus 0.02 is 1.02 raised to the 12th power. And I would make sure you multiply that 4 times 3 right away to give you a power that's just a single whole number there. So if I'm looking at this again on the calculator, you could type this in. If you have one that displays everything on the screen, is 4,000 times 1.02. We're going to put that in parentheses. You don't necessarily need it, but let's just do it just to make sure. All right, and then we're raising that part in the parentheses to the 12th power. We hit enter on it, and we get A equals, we got 5,072 point, now we got 967. Remember, I want 2 decimal places, so that 7 is going to tell us to round that 6 up to a 7, so 0.97 is 97 cents. Remember, this is money, that's why I'm using 2 decimal places. So the amount in the account after 3 years when compounded quarterly would be $5,072.97. Again, if you had a calculator that didn't display everything on the screen, you would multiply, or you would raise the 1.02 to the 12th power first, then multiply it to the 4,000 to get that number. So, you know, these problems were set up similarly. You know, the problem I had on the previous page had the same principal and the same interest rate, but how often it was compounded changes this. If I flip back to the previous page just for a minute, it was compounded annually, and you know, we had the same principal and same interest, but compounded annually, I only made $5,038.85 in the account. You know, compounded quarterly, I have $5,072.97. So the moral of the story here is interest being compounded more often, if you were given the same interest rate and the same principal, will definitely give you a better result because you'll always have more money you earned in interest. You know, so if you're comparing these, you would be able to see that. If I asked you the type of question where I said, you know, find the amount that was in the account after 3 years, but also how much did you earn in interest, well, you would just take the total amount in the account and then subtract off the interest, or subtract off the principal, and you would be left with the interest in the account. So if I wanted to know how much they earned in interest, you do $5,072.97 minus the $4,000, and that would leave you with $1,072.97 earned in interest. So hopefully this was mostly review for you. As you approach the homework for this section, you know, you'll see problems where you're asked to graph. You'll see problems where you're asked to use this formula. So make sure that you do refer back to this in your notes. And that will be the end of the first review topic.